Okay, so we're looking at the derivative of b to the power of x. We know that the derivative of e to the power of x is itself, but when we have a different base, what do? Here's the proof, or how we derivate this, okay? So if we have e to the power of ln b, we know that that equals b, right? If I have actually this b to the x, that's actually the same as putting the x up there, right? When you have an exponent in a logarithm, that exponent can be written like this. It comes down in front, remember? So this is kind of what we've got. We've got e to the ln of b times x. Okay? That's the same thing. Equals b to the power of x. Now if I take the derivative of both sides, or if I'm really finding the derivative of b to the x, it's the same as taking the derivative of this right here. Okay? So the derivative of this right here, it's e to some power, right? So we'll use the chain rule. The derivative of e to something is e to that same something times the derivative of the something, right? Times d over dx of ln of b times x. Okay? So this right here now, I need to take the derivative of this right here, but ln of b is a constant. So, buttons. So e to the ln b to the power of x, or times x up there, is the same as, this can come out because it's just a constant, times ln of b, and then we find the derivative with respect to x of x. So this is e ln b times x times ln of b, and then this is 1, the derivative of x, right? Right? So this is where we go back to the beginning of the question, and what is e ln b? What is e ln b? That is, e ln b is b. So really, you could be done here, but we know that this equals something else. This is b. And so if this was to the power of x, then b would be to the power of x. And then you have times ln of b times 1. So this is what the derivative of b to the x is right here. Okay? So that's your formula. So you need to write this down. Make sure that you have this, the derivative with respect to x of b to the power of x. So that's any base, doesn't matter what it is, 2 or 4 or 10. Okay, is b to the x, so it's the same thing, times ln of b. An example would be this. I'll show you in a second. Make sure you write that down. So the example would be, here's your function, y equals 10 to the power of x. What's y prime? Okay, go ahead. What's y prime? Y equals 10 to the power of x. Okay, you solve it. Go ahead and use what we just established there. Okay. Should be done. Go straightforward. Right? So the derivative of 10 to the x is 10 to the x times ln of whatever the base is. Got it? Yep, that's all you need to put. Now, ln of 10 would actually be a number you can calculate, but it would be a long decimal number, so it's best to leave it as ln of 10. Right? Pretty straightforward? Okay. So the last part then is, what is the derivative d over dx of log of x? base b. So what if we don't have natural logarithm? Or what if we don't have, what if we just have a logarithm with a different base other than, a 10 or 2 or 3 or 5 or whatever? So how do we find that? Okay, so what's the derivative? So if we start off with log of x base b equals y, then we have this can be written as b to the y equals x, right? So logarithmic to exponential. So if we take, we're going to try and find y prime here then, right? Y prime. So if I took the derivative of both sides, what would I get? On the right side, what's the derivative of x with respect to x? 1. What's the derivative of b to the power of y? What did we just do here? So b to the power of y times ln of b times what? Thank you, times y prime. You bet. Because this is y, not x, so we have to do chain rule. So y prime then, we'll just divide both sides by this. Right? 1 over b to the y ln b. We'd finish this off by saying, hey, what is b to the y here? Look at this. See, b to the y is what? Actually equals x, right? So 1 over x ln b. So here's our final answer here. So write this down, d over dx of the logarithm of x base b is 1 over x times ln of b. Okay? So you can add that to your derivative chart. You've got a whole bunch of derivatives now, sine, cosine, and tan, and exponential now, and the logs. So you can add that to your arsenal. Whenever you need to find the derivative of a logarithm, then you know how to rewrite it. Okay? And if this was something other than x, then what would you do? If this was something other than x, if it was u, right, some other function, then this would be u, the function, and then you would times u prime, right? So you do chain rule if it wasn't x, which I can write that down if you want. d over dx of log of some function, and let me put it in f of x terms for you. The derivative is going to be 1 over f of x ln b times the derivative of f of x. So there's your two derivatives for today. The derivative of log of x base b and the derivative of b to the x. Okay? Questions? Okay, here's the rest of your assignment.